Hey there, I'm Nix, and the topic of today's video is solving the add binary problem on the LeetCode website. As always, solving this problem in the C++ language and giving you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of time and space complexities. If that sounds good to you, then stay tuned. Welcome back, and let's get started. We're given two binary strings, and yay, we're in the string section. We're doing something other than arrays, if just a little different. Anyway, we have two binary strings, A and B, and we want to return their sum as a binary string itself. And we're given two examples here. A is 1, 1, B is 1, and thus when you sum those together in binary, you get a binary answer of 1, 0, 0. Now, that brings us to the first topic we need to discuss in the process of solving this problem: understanding how binary addition works. Now, binary addition is pretty much, in terms of concepts, essentially identical to regular old addition that you learned way back in your beginning elementary school days. So let's use this example as, well, an example, and bring out my handy dandy whiteboard. So we have A and B here, and we want to add those binary numbers. And much like in a regular addition, you start at the rightmost column and you add them up. So 0 plus 1 is equal to 1. But now we get to adding 1 plus 1. And much like in a situation where you have, say, trying to add the digits of 9 and anything else, like 9 plus 2. Well, our digits in a base 10 system only go from 0 to 9. So what it does is roll over back to the beginning, and you need to plonk in the appropriate digit as well as carry over the other one. In a similar fashion, 1 plus 1 in our normal system would equal 2, but 2 doesn't exist in binary. It's just zeros and ones. So, much like in the other situation, it overflows, and we start back at 0. So 1 plus 1 in binary is 0, and we carry that 1 over to the other column. We have a 0 plus 0 here, which would be, unsurprisingly, 0. But we have a 1 in the carry column up above it, so we add that as well, and we get 1. We see 1 plus 1 again. That overflows, we put in a 0, we carry over 1, and the only thing in that column is 1, so we just directly carried it down to get the answer that we expect. So, with understanding binary addition, let's move on to looking at the constraints here. A length and B length could be anything from 1 to 10 to the 4th here, and as we see in the example, we have no guarantee that both of them are the same length. A might be longer, or B might be longer, or they may be the same length, which can complicate factors for us. Since they're binary, obviously A and B only consist of 0 and 1, and each string does not contain leading zeros except for the 0 itself, which means, yeah, their lengths can definitely vary. It would be nice if the leading zeros were a thing, because then they would always be the same length no matter what. And of course, this constraint here essentially hands you the way to solve a potential problem on a silver platter. Well, if the string doesn't contain leading zeros, then let's just put those leading zeros in to make sure that A and B are always the same length. That way, as we loop through the string, once we reach the end of the string, then we know we've seen everything in both A and B if the shorter one has been padded with leading zeros. We aren't going to get any out-of-bounds index errors as a result. So that's great. That solves one potential problem. But of course, now we need to figure out, well, how do we do binary addition with this problem? And this is where my handy-dandy whiteboard comes back to shine. Alright, let's make a couple of rows here. Let's put down what A equals, what B equals, what carry could equal, and let's put in what all of those summed up equals. And let's see about finding some patterns here that can be useful to us. Well, A and B could have 4 possible scenarios. They could both equal 0. A could equal 0. B could equal 1. We could have the reverse with that. A equal 1, B equals 0. And of course, they could both potentially equal 1. Now we can have a repeat of all of those. And the only difference between this set and this other set is in this first set, we don't have a carry value to worry about, so it's 0. And this other set, we do have a carry value to worry about. So those are all of the possible situations that we could potentially see. Now let's sum everything up. And here we go. So we see here that we only see 4 potential values, 0, 1, 2, and 3. Now that we have this information, let's do some analysis on this and figure out what our answer would be. In other words, what is the character, a 0 or a 1, that we're going to add to the string that's eventually going to house all of those characters and be our final answer for the entire problem. So let's do some binary addition. Everything being 0, well, that's always going to be 0. Looking at carry A and B here in the second column, B is 1, everything else is 0, so that would end up being a 1. Same thing for this next column, it would be a 1. And when we get to A and B potentially both being 1, we know that will lead to a value that we put into the string of a 0 because of the overflow nature. Now looking if this result is going to end up having to have a new carryover to the next column. Well, these first 3 situations, no. We need to have both A and B be 1 for this situation to happen because carry is always equal to 0. That's not going to help us. A and B being 1 in this last column means that we will have a 1 to carry over to the next column. So that gets a yes. All the rest get a no. Let's move on to the situation where carry is equal to 1. The first thing we want to do is evaluate A and B. First column here, binary addition of 0 and 0 is of course 0, but carry being 1, we add that as well, so we get a value of 1. Now in these next 2 situations, either A or B is 0 and the other one is 1. So when you add those, you get a 1, and then when you try to add that result from A and B to carry, you get in a situation where you're adding 1 and 1, so we're getting to the overflow result, our answer is a 0, and we have a new carry over to take into account. This final situation, A and B results in a carryover, so it turns it into a 0. And then we add that 0 to 1, and then we get a 1 here as our final answer. And of course, since we generated a 1 plus 1 result here with A and B, that generated a carryover, so that's a yes as well for the new carry. And with all of this information here, we can now see how to solve the problem. Looking at our sum, and looking at our answer, you see when the sum of all of the values is equal to either a 1 or a 3, our answer is going to have a 1 added to it. When it's 0 or 2, the answer is going to be a 0. And you can also see when either we're dealing with a 0 or a 1, we don't have a new carryover. And when we have the sum being a 2 or a 3, we do. So with those pieces of information, we can sum all 3 of these things, carry, A, and B in integer form, sum that result, and then depending on that sum, we automatically know how to assign what carry is going to be and what our answer value is going to be. Then we just loop over the entire string in reverse. We start at the end, go to the beginning, and then can use the sum to assign everything. And then at the end, we just need to return our answer. And the final thing we need to look at is if we still have a carryover at the very end of our loop. If we do, well, we just add that to the front of our answer. If we don't, well, then our answer is perfect the way it is, and we can just return that. So in summary, for our first code version of this problem, we're going to need a couple of variables. We're going to need a sum that is an integer, or a short could also work. We need a carry integer, or again, sum. And of course, we need our string answer. The next thing we need to do is pad our input strings. Whichever one is shorter, we're going to put leading zeros into in order to make A and B the same length. That means when we go into our reverse for loop, that for loop is going to be able to go through and look at the entirety of A and the entirety of B. So we don't need to worry about cascading while loops and all of that. One simple reverse for loop will work when we have those leading zeros present. And that for loop is going to do some conversions for the string digits to integers, sum all of those digits up, and then use that sum to assign what the answer is and what new carry is, and build up our new string answer with each of those digits. Finally, at the end, we look at the carry value one last time and use that to determine whether we have to plop a 1 before our answer, or we can just return answer. And that is all of the parts of this code, so let's move on to actually making that code a reality. First up are the variables. I've made 2 shorts. These could also be integers. Shorts just take up less memory space, so it's a little bit of an optimization relative to using integers. I named one carry, set that equal to 0, named the other sum, set that equal to 0, and finally we have our string that I named answer, and it's just empty at this point. Next up is the if-else statement to handle the varying lengths of A and B that are possibilities, and we do that by adding the leading zeros. So if A.size is bigger than B.size, B is the smaller one, we want to pad B. And the way we do it is by string concatenation. We want to first subtract A size and B size. That tells us how many leading zeros we need. What we want to add is the 0 character, and we convert that to a string. Now, because leading zeros are leading, we want this to be first, and then we want to add in whatever else B is initially equal to. So we concatenate this section, the leading zeros, with our original B string to get the new and improved version. If A is the one that's smaller, well, we do pretty much the same thing and subtract B from A to get the number of leading zeros, and then everything else is the same. Here's the beginning of the for loop. Again, we want this to be a reverse for loop, so I is initially set to, you can do A.size here, you could do B.size here. Since after this if-else statement above, they're going to be the same thing anyway, so you can use either one. So A.size minus 1 is the maximum index for it, starting at the very end, and we go as long as I is greater than or equal to 0. And finally we decrement I every time. Now, the first thing we want to do is figure out what sum equals, and we need to add the value of A, B, as well as carry. Now, carry is nice and simple to be added because carry is already a short. It can house numbers, but the digit that's present in the string A and the digit that's present in the string B, A of I and B of I, are characters. They're not numbers. So the thing that we need to do first is convert that character to an actual number. And the way we do that is by this line of code. This is just a bulkier version of this. In both situations, you're casting A at I and the 0 character as integers. This lets you subtract their ASCII codes from one another, and the digits from 0 all the way to 9 are one right after each other. So that subtraction essentially is a way to convert the digit characters to their actual number form. And of course this can be plopped into a short as well. If you just did this and attempted to transform the character itself to an integer, you'd get its ASCII code instead, and that would mess everything up. You want the actual digit you're looking at, 0 or 1 in our case, to be transformed into the number 0 or the number 1. And this doesn't do it, so that's why you have this subtraction going on. Anyway, we have the number that's represented by A at I. We have the number that's represented b at I, and we have carry. And we add all of those up, and that'll give us our sum. Now what comes up is, since we have this sum, and from our previous analysis, we know what our answer is going to be and what our carry is going to be in each of these situations. So if sum is equal to 3, well, our answer is going to be string concatenation of the one character with whatever the rest of the answer was. And our carry is going to equal 1. With sum being 2, we need to add a 0, and carry is still equal to 1. If sum is equal to 1, our answer is equal to 1, but carry is equal to 0 this time. And finally, if sum is equal to 0, the only other possibility, but an else works just as good as an else if, then our digit to add is 0 in front of whatever the rest of the answer is, and our carry is also equal to 0. Finally, we have our if-else condition that determines what we return. If carry at this point after the loop is equal to 0, we return answer, else we return the string concatenation of 1 plus our answer. And with that, this code is complete and shouldn't have any issues. So let's prove that. Let's run code, pending judging. Excellent. We see with this example, we get exactly what we expect. Great. Let's go for the full shebang. Pending, judging, and green text. Excellent. So this works. Looking at time and space complexity for this thing, we have some constant space usage for these short variables, but what's basically going to dictate it is this string value here. The string value is going to end up being at its maximum whatever the size of the larger of the two input strings is, potentially +1. But the +1 is a constant, we don't care about it. So this string answer is essentially dependent on the larger of the two string input sizes, which we can say equals n. So this code would have a space complexity of, say, big O of n. For time complexity, we have some string concatenations happening in various parts of the code. We have a loop being created. So the biggest thing that's going to impact the time complexity is the for loop and how many times it runs, as well as time complexities of string concatenation. String concatenation can be uncertain, but it can generally be linear in terms of the string size. And of course, the for loop is also linear in the string size. So combine those together and you're going to have a big O of n squared time complexity, where n is the size of the bigger string. And with that, let's look at the LeetCode rankings. Okay, 12 milliseconds, really small distribution range, so I'd expect it to ping pong around these quote-unquote distribution columns here. And memory usage is around this area, but again, this is also fairly small memory range, so that indicates to me, for looking at these charts, that there's not much variation in terms of different types of answers that have different time and space complexity with them. So these are probably all on the order of big O of n's, and thus we could probably potentially see some ping-ponging happening. Alright, now the last thing I want to do is take this code and show an alternate version for it. Now here, we're going to do the same basic thing, except we're going to make use of the Bitwise operators. And the two that are going to be useful for this problem are going to be the Bitwise AND and the Bitwise XOR operator. Those two operators can reduce the number of if-else-if statements we need and can essentially automatically find what our answer and what carry should be. So let's bring back the whiteboard with all of that previous information, and let's look at it again. Let's talk about bitwise AND first. Let's look at A and B. If we're using the bitwise AND operator on A and B, then that's only going to give us a 1 when both A and B are 1. Any other situation is going to give us a 0. And now let's look at our new carry row here. That's exactly the result we want for determining whether or not we have a carryover value. These first 3 columns here all have a negative result. It's only when A and B are both 1 that we have a positive result, i.e. we get a 1. Now in this situation, that works perfectly. But because we have an additional factor of carry to take into account, we can't just simply rely on A, bitwise AND B, and get everything right. Because as you see, once carry equals 1, that falls apart. However, what if you look at all 3 possibilities? Let's bitwise AND A and B together. Let's also do that for A and carry. And finally, let's also do that for carry and B. And let's see what all of those add up to be. Well, in the first section here, with carry always equal to 0, you're never ever going to get into a situation where our bitwise AND is going to end up with a 1 result whenever carry is involved. Because both of them have to be 1, and since carry is always 0, we're never going to get a 0 when we do a bitwise operator with carry and anything. In the other section here, when we do bitwise operators, let's look at what happens in this row here. Carry is equal to 1, B is 1 as well, but A is equal to 0. When we do bitwise AND with A and B, we're going to get a 0 result. Same thing occurs if we do a bitwise result with A and carry. We're going to get 0. But B and carry, both are equal to 1, that's going to give us a result of 1 as well. Exactly what we want to see for our result for our new carryover. So, if we set carry equal to the bitwise AND result of A and B plus the bitwise AND result of A and carry plus the bitwise result of B and carry, that should automatically crunch this number analysis that we're doing manually right now and give us the result that we want. And that's going to work for this entire first section. It's going to work for all of these 3 situations here where carry is equal to 1, because in all of those situations we either get a 0 when we want a 0 or we get a 1 when we want a 1. But look what happens at the final column here where everything is equal to 1. Bitwise AND of A and B is going to give us a 1. Bitwise AND of A and carry is also going to give us a 1. And, you guessed it, bitwise AND of B and carry is also going to give us a 1. So in this situation, and only this situation, we get a carry result of 3. However, we can easily deal with that. In our loop, the first thing we want to check is if carry is equal to 3. And if it is, we're going to say, no. You don't get to equal 3. Carry is equal to 1. We just reset it, and then all of our problems go away. So as you can see here, using the bitwise AND operator to figure out what carry is going to work perfectly if we have that if statement checked beforehand. Now what about sum? Well, let's look at this first set of scenarios, and let's look at our answer here. When either A and B are both equal to 0 or both equal to 1, we get a 0 result. When one of them is equal to 1 and the other is equal to 0, i.e. they have different values, then we get an answer of 1. So when A and B are both equal to the same value, we get a negative result of 0. When A and B are different, we get a positive result. And that is exactly the truth table that XOR gives. So if we use the bitwise XOR operator on A and B, that's going to automatically evaluate the answer for us. But like we saw with carry, we can't just do it with A and B and call it a day. We have to take carry into account as well. So let's look at the second set here. Say this first column in the second set. A and B are both equal to 0. So that results in a positive XOR bitwise evaluation. And our answer is going to turn into 1. Then let's do the same bitwise XOR with carry. We get an evaluation of that result of 1 we bitwise XOR with carry, which is also equal to 1, and hey, carry and that prior result are both equal to the same value, so we still get a positive result of 1, which is exactly what we want. In this situation here, A and B are different. That evaluates to a result of 0. And of course, carry being 1, that result being 0, well, those are also different, so that final result is going to be 0 as well, as we see in the answer. So, doing a bitwise XOR operation between A and B, and then whatever that result is, doing another bitwise XOR operation with the carry value will automatically handle all of these situations, as long as carry is correct. So with those pieces of information, we can now get rid of all of these if-else statements. We don't need it. And we can get rid of this and alter the code here to incorporate the use of those bitwise operators. First thing to do, guard against the potential for carry being equal to 3 and reset its value to 1, which is what it should be equal to in that situation. Here is the code for what I was talking about using the bitwise XOR operator here, which is the little caret. We still have to use the actual numbers instead of the characters here, so we still have to do the conversion. But essentially this is a bitwise XOR between A and B, and then whatever that is, you're going to have another bitwise OR operation between whatever that result is, and carry. Now for what carry equals, and this uses the bitwise AND operator here. And all these parentheses is to make sure the order of operations is correct. I want it to handle the bitwise AND operation between A and B first, handle another bitwise operation between B and carry, and finally a third bitwise AND operation between A and carry, and then add each of those up. And that is what carry is going to be equal to. Finally, since sum is going to house our answer after this operation is evaluated, we want to add that in front of our old answer by first converting whatever sum is to a string, and then handy-dandy string concatenation happens and builds up our answer. These 3 lines handle everything that the if-else-if branches from the previous one handled. And at the end, we still need to do this if-else check. And with that change, we will see that this code works as well. Fingers crossed, unless I made mistakes. Okay, that's a good sign. Let's submit, pending, judging, and more green text. Excellent! This essentially has the same time and space complexity as the previous one. It's just an alternate version that uses the bitwise XOR and AND operators and condenses if-else checks. Plus, bitwise operators have a tendency to be very efficient when you're actually dealing with bytes. So let's look at the code rankings here. Hey, I ping-ponged up here. And I'm around this area as well. Okay, cool. So that was how to solve the add binary problem on the LeetCode website. I hope you got something out of this video. If you did, consider subscribing. I do these types of videos twice a week. And as always, I will wish you happy coding and to have a nice day.